Okay, so today we're going to look at some problems from section 3.5 in our textbook, solving nonlinear systems. Generally what that means is one or both of the equations will be a quadratic. They could be parabolas, circles, hyperbolas, ellipses, but for our purposes, we're really just concerned with a algebraic approach, so we don't have to worry about the actual shape here. A lot of this is because we haven't learned how to graph some of these shapes. Certainly we've done parabolas, but we have not done the other conic sections as we call them. Okay, so in problem number one, we have two equations. We have a parabola, and we have an x squared, so we know that it's a parabola that opens up or down depending on our final a value, and we have a linear equation. And since we have one already set up, y equals, I'm going to use substitution. But one of the things to be careful about is notice that I am subtracting y. So over here, I have minus. So I'm going to use parentheses because I have minus the whole y expression, which is the 7 minus 2x. So technically, that's a negative 1 times y. So then we'll have a minus 7 plus 2x. And I'm going to subtract 5 now because I know with my quadratic I'm going to set it equal to 0. I have x squared, combining like terms, 4x minus 12. This is a good one for us to factor. So two numbers that multiply to negative 12 and add up to 4 are positive 6 and negative 2. And then again, applying our zero product property, we get x equals 2 and x equals negative 6. Okay, so those are the two x coordinates. So we appear to have 2 points of intersection. Now we want to find the y coordinates, so we're going to plug it back into either equation. I'm going to choose the linear one because it is the easier of the two. So 7 minus times a minus is a plus. So we have y equals 19. So we have the coordinate negative 6, 19. And then the other coordinate, 7 minus 2 times 2. So we have 7 minus 4 is 3. So the other coordinate is 2, 3. So there are the 2 points of intersection for these two equations. Okay, moving on, we have two quadratics. And I notice here that I have a negative 2y and a positive 2y. So for me, this sets up real nice for an elimination. So I'm going to use the elimination method because when I add the two equations, because my coefficients are opposite, they will add up to 0, which means I have 0y, and therefore the y's will be eliminated. So I have a 4x squared, a minus 4x equals, and that's a negative 2. And so now I've got to decide, do I want to factor? I'm going to use completing the square, just so that you can see an example of that. So I'm going to divide everything by 4. So x squared minus 1x equals negative 1/2. And so then I'm going to take half of negative 1, which is negative 1/2, square that, and we get positive 1/4. I add, 1/4 to both sides, and we end up with x minus 1/2 squared equals negative 1/4. So now I know in my next step, I'm going to take the square root of both sides, and I see here on the right side that I'd be taking the square root of a negative, and so therefore I know there is no real solution, and that means that there are no intersections. Okay, because we would end up again with an imaginary solution there. Okay, so our last problem here, we have a circle, and again I wouldn't expect you to know that necessarily yet, and a parabola that opens sideways because it's y squared. And so you've got some choices about how you want to solve this. I think I like the idea here of doing a substitution. And so what I'm going to do is I'm going to solve this equation for y squared. So over here I'm going to write y squared equals 1 minus x squared. And now I'm going to substitute into the other equation. So I have 2 times the expression 1 minus x squared equals x plus 2. 2 minus 2x squared, right? We're distributing the 2 equals x plus 2. So again, we have a quadratic. And I'm going to put everything on one side. So I'm going to subtract 2, and that'll be 0. Add 2x squared. And so I have 0 equals 2x squared plus x. All right, so it's not a trinomial, so I'm not going to factor this in the typical way of two binomials, and especially since it's not a difference of squares. But I notice that I have an x in both terms. So I'm going to factor out the x to leave me with 2x plus 1. Now when I apply the zero product property, x equals 0. And we have 2x plus 1 equals 0, so x equals negative 1/2. All right, so there's the 2x coordinates. So now I'm going to go back and I'm going to choose this equation because I think that may be a little simpler. And notice when I substitute 0 back in, that's 0, so we take the square root of both sides. We get the absolute value of y equals 1, and so we get two answers. So we end up with both 0, 1 and 0, negative 1 as our solutions. And now when I substitute negative 1/2 back in, we get negative 1/2 squared plus y squared equals 1. 1/2 squared is 1/4. Subtract 1/4 from both sides, and we get 3/4. Now when we take the square root, we get the absolute value of y. On the right side, I end up with root 3 over 2, because the square root of 4 is 2. And so y would be plus or minus root 3 over 2. So again, when x is negative 1/2, we end up with two solutions. So we end up with root 3 over 2 and negative root 3 over 2. So here's a situation where we have a circle with a radius of 1 centered at the origin. And again, I would not necessarily expect you to know that. And then we have the parabola that opens to the side. And so we end up with, as it turns out, 4 solutions. Hope that helps.